We are introducing today two-column proofs. It is another type of proof. It still has all the same components that our paragraph proof did. It uses our givens, assumptions that we can make, definitions that we have to prove what we are being asked to prove. It's just formatted a little differently. So with two-column proofs, we have two columns. One column is going to be our statements, and the other column is going to be our reasons or supports for those statements. So the easiest way to understand this is to go straight into an example. So on this first problem, we're told that angle A is a right angle. So I'm going to mark that on my diagram. And we're told that angle C is a right angle. So my first two statements and reasons are going to be that given information. So remember, with our paragraph proofs, our introduction, it usually started with what we were given or our diagram, things that we were going to use to show that these were right angles or congruent angles. So statement one, angle A is a right angle. Well, the reason I know this is because it was given to me. So my reason for that statement is that it was given. Same thing for angle C. We were told in our givens that angle C is also a right angle. Okay. Now, just from that information alone, angle A being a right angle and angle C being a right angle, we need to find a theorem in our dominoes, and I have them handy here, right here where it's highlighted. If two angles are right angles, then they are congruent. This is a theorem from 1.4 in our book. So that is going to be my reason to then state that angle A is congruent to angle C. If two angles are right angles, then they are congruent. And you can use some symbols and shorthand to save yourself some of that writing. And I'm just going to refer to that this was from page 1 of my dominoes. Okay, so if you look in page 1 of your dominoes, this is page 1, that's where that theorem is. Okay? So that's not too bad, right? Let's go on to number 2 then. We are given the diagram, so we have these two lines, and we want to prove that angle ABC is congruent to angle DEF. Now this one, the statements are already written for us, and we're going to be matching the reasons for this statement, just like we did in number 1. So the first statement is the diagram as shown. How do we know that? We were given that, okay? Statement 2 is that AGD, and I apologize, that should be ABC. So this should be angle ABC, and this should be angle DEF. Okay, so we know that angle ABC is a straight angle. How? Because we can assume straight angles. So our reason would be assumed from the diagram. If we didn't have the diagram, we could not assume that. So it's assumed from the diagram. Okay, same thing for angle DEF being a straight angle. This was assumed from our diagram. So up to this point, I have shown that I have two straight angles. So if I want to say that those two straight angles are congruent, I can pull this theorem. This is page 2 of our dominoes. If two angles are straight angles, then they are congruent. I have two straight angles, so if two angles are straight angles, then they are congruent. And I'm just going to reference that was from page 2 of my dominoes. That's where that theorem came from. On to the other side, number 3. We are told that angle PRS is a straight angle, or sorry, excuse me, it's a right angle, so I'm going to mark that on my diagram. I want to prove that line PR and line RS are perpendicular. Remember, that symbol means perpendicular. Oops. So, my first statement is that angle PRS is a right angle, and I was given that. We could not assume that from our diagram, even though we have the diagram. This was given. It was not assumed from the diagram because we cannot assume right angles. Okay, then I'm ready to go ahead and say that these are perpendicular lines. So if I look through my dominoes, this is on page 3 of the dominoes. Here I have this theorem, it's a definition. Lines, rays, or segments that intersect at right angles are perpendicular. Now, because this arrow right here goes both ways, that means it could apply in the reverse. If these lines form a right angle, then they are perpendicular. So our reason would be lines that intersect at right angles are perpendicular. And that was from page 3 of my dominoes. Okay. All right, we've got one more here, and this time the statements are not already written for us, so we have to put these in sequential order. So we're given that AB is perpendicular to BC, and we're given that DC is perpendicular to BC. And we want to show that angle B and angle C are congruent. So, thinking logically through the order of your statements, there is a couple different ways that you could order your statements and reasons as long as the reason matches the statement and as long as it still shows what needs to be shown. So, we know that these are perpendicular lines, so we already know that these two angles are going to be right angles. That's what we know. Those are conclusions we can draw. So in order to state that angle B and angle C are congruent, I have to first prove that each of these angles are right angles, because one of the theorems that we've already used is that if two angles are right angles, they are congruent. So my last thing is going to be that angle B is congruent to angle C. Okay? That's going to be our last statement. So sometimes you might work backwards, sometimes you can work and figure out what's in the middle. So that's going to be my last statement. And we always want to start out with what we're given. So I was given that segment AB is perpendicular to segment BC. I was given that information. Okay? So from that, I was able to say that angle ABC is a right angle because if two lines are perpendicular, then they form a right angle. Okay. So I was given this information, and this was a conclusion I could draw from that given. Okay. The next thing I was given is that segment DC is perpendicular to segment BC. And again, my reason is that was given information. Okay, so what I can assume from that is that angle DCB is a right angle. And I apologize. I'm going to remark these angles as B and C. Angle ABC, remember we can just name that as angle B by the vertex. And I'm going to do the same thing here. Angle DBC, we can also just call that angle C, since that's how it's asking me to prove it there. So angle B is a right angle, and angle C is a right angle. And then my reasoning for angle C being a right angle is the same. Again, if two lines are perpendicular, then they form a right angle. Okay, so I used my given to show that B is a right angle. I used my other given to show that angle C is a right angle. Now that these are both shown to be right angles, I can say that they are congruent because of my theorem. Remember back from page 1 of my dominoes, if two angles are right angles, then they are congruent.